Okay, guys, I'm back. Sorry about that. I literally could not wait one more second. So, we are back right exactly where we left off. We just finished the radical one, and now we are on to finding domain and range. And this time, because we're finding the range, I'm going to draw pictures that go along with this. So, you can easily put this function into Desmos or just Google it. And y equals the absolute value of x is a very basic function. And I'm going to draw a picture of it up here so that we can take a look. Absolute value functions take each x, whether it's negative or positive, and output a positive value because that's what an absolute value does. If I plug in 0, obviously I get 0, but, all right, seriously, I'm about to just go find one and cut and paste it in here. 0 gives 0. If I plug in 1, I get 1. But if I plug in negative 1, I also get 1 because the absolute value of negative 1 is 1. Negative 1, 1. If I plug in 2, I get 2. But same deal with negative 2 because the absolute value of negative 2 is also 2. So it's going to end up making this V shape like this. Or, you know, nicer than how I can draw because I'm doing a terrible job. All right, so V shape. This picture gives a really good idea of what the domain and range are because you can now look left to right and bottom to top. For the domain, we've got left side arrow, right side arrow. No breaks, it's continuous. Left arrow means negative infinity. Right arrow means positive infinity. And we probably knew that already because it's not one of our exceptions. The exceptions are rational and radical. This is not one of them. So the domain is negative infinity to infinity. Now the range is going to go from the bottom of the graph to the top. The bottom of this graph is an ordered pair, point. We want the y coordinate from that point, which is 0. That's as low as it goes. The highest part of this graph is up here, 2 arrows pointing up at the sky. Up arrows are going towards positive infinity. So there's your range. Now, x equals 3 is a vertical line, which we graphed in the last unit. Vertical lines just go straight up and down. Oh my gosh. I can't get it together here. Straight up and down, like so. Now, I'm going to start off right off the bat and say this is a special case. This is what I was talking about before when I said there's an exception to this little everything else rule. This is one of the exceptions. The reason why it is an exception is because it is not a function at all. So it doesn't follow the same rules that the functions do. I wrote not a functions. Not a function. Then I erased part of it that I didn't want to. Function. Okay. When it's not a function, it doesn't follow the same domain and range rules necessarily. So we want to take a look at this thing. The leftmost x on this graph is 3. And the rightmost x on this graph is 3. So the only x on this graph is 3. And that means the domain is 3. And the way that you write it is this weird looking closed interval from 3 to 3. That means you're touching 3, you only go to 3, you never go outside of 3, and you kind of just are always on it. Now the range goes from bottom, that's a negative infinity, to top, which is a positive infinity. Another example of something that doesn't follow the rules that just kind of popped right into my head is a circle. Circles don't have domain negative infinity to infinity. You have actual domain that you can see for those, and that's because circles are also not a function. Horizontal lines are functions, so they will follow the rules. And you can take a look at one if you like, and it does have domain negative infinity to infinity. It's the range that's a little bit weird on that one, but that's okay. It's still a function, so it follows the domain rules. So there's a couple examples looking at domain and range, including a special case. Now, the last thing that we're going to do is a difference quotient. A difference quotient is used to find the slope of a secant line, and we're not really going to get too into it here because this is something we save for more like in calculus. They talk about difference quotients when you're doing calculus with algebraic methods. So we're just going to use it in the sense that it is a function and it's manipulations of functions. Now, when I do a difference quotient, because there are several pieces to it, I do them one piece at a time. So the first thing that I would do is find f of x plus h. F of x plus h is where you are going to input x plus h, the expression, into your function and simplify as much as you can. Once you have completed that part, you will subtract away the original function itself. So you'll have some big long expression and you'll take out the original function. That's the second step. Once you have simplified that as much as possible, the last thing is to divide everything left by h. Step 3. So it's kind of like a 3-step process. And if you don't look at it as a giant whole ugly formula, it's a little bit easier to deal with, taking it step by step. So that's how we're going to do these. And there are 2 examples. The first one is a quadratic. And so I'm going to begin step 1 by replacing the x's with x plus h. So f of x plus h gives me 5 times x plus h squared plus 4 times x plus h. Order of operations says exponents first, so I'm going to FOIL this out. X plus h times itself. And I get x squared plus xh plus xh plus h squared. Combine like terms. This is x squared plus 2xh plus h squared. That's just the FOILing part. Now I've got to multiply all this by 5 and also distribute a 4 through the second x plus h. So we multiply. 5 times x squared, 5x squared. 5 times 2xh is 10xh. 5 times h squared, 5h squared. Distribute the 4 times x, and 4 times h. Now, it kind of stinks, but all of that is f of x plus h. So that's the first step done. Second step says subtract out the original function minus the original function is 5x squared plus 4x. This is step 2. Now, when I do that, subtracting a polynomial means this negative is going to kind of distribute in here. And it's going to turn this into a negative 5x squared and a negative 4x. Now, that's going to be helpful because these two terms are going to end up canceling some stuff out. 5x squared minus 5x squared cancels. Positive 4x and negative 4x cancel. So really, its whole purpose is just to kind of get rid of some stuff. And now we're left with 10xh plus 5h squared plus 4h. Whoa. Step 3, last step, says take everything and divide it by h. This is going to allow us, again, to cancel some stuff out. In the first term, the h's cancel. I'm left with 10x. In the second term, this h cancels one of these ones out, so I'm left with 5h. And in the last term, the h's cancel. I'm left with 4. And here is your difference quotient. So taking it step by step, not terrible. It's just a little bit tedious because you have to FOIL and distribute and combine and cancel, and so it just is a little bit much, but nothing too crazy or difficult. Now the last one here, excuse me, is a rational equation. And we are going to do the same thing to find our difference quotient. We start off with, first step, f of x plus h, which means that everywhere we see an x, we're just going to replace it with the expression. Well, that's really easy. There's only one x in there, and it's on the bottom. 3 over x plus h. Well, that's done. Step 1. Step 2. Subtract out the original function. Step 2. Now, here's where it kind of starts to get a little bit because that's a mathematical term. We need a common denominator. This is a binomial, this is a monomial, which means they don't have anything in common. That also means I'm going to have to bring an x in on this side and an x plus h in on this side. So on the left, I've got 3x over x times x plus h minus, I've got to distribute here, 3x plus 3h over x times x plus h. Now, I want to combine some like terms here because we are subtracting two rational expressions. Remember, subtraction means adding the opposite and combining like terms. When I combine the like terms in numerator, the 3x's cancel each other out, which is great. I'm left with negative 3h over x times x plus h. And then step 3 says, last step, I'm supposed to divide by h. Now, since this is a rational expression, instead of dividing by h, I'm going to multiply by the reciprocal. So negative 3h over x times x plus h. Don't divide by h, multiply by 1 over h. And how nice for us, it lets us cancel these h's. And my final answer is -3 over x times x plus h. So even though that one involved rational expressions, it actually was a little bit shorter to do than the first one. But it's the same concept, three-step process. Plug in x plus h and simplify. Subtract out the original function, divide everything by h. So I hope that this helped. Next video will be for section 3.2, looks like 3.2a and b, I guess, all of it together, which is talking about linear and quadratics. And then we'll talk about like some specifics, max and min applications. So be on the lookout for that, and let me know if you guys have any questions.